Well, one benefit of this center-surround antagonism is that what these ganglion cells really convey to the brain is a signal not so much about the overall illumination of the environment, but rather about contrast, about an edge of light that might just be perfectly dividing the center from the surround region for any one receptive field structure. Well, with this sensitivity to contrast, the retina now can respond over a tremendous range of environmental conditions. What we're looking at here is a plot that illustrates the dynamic range of the response of a ganglion cell, and each of these lines here represent the discharge rate of a ganglion cell over some range of test spot illumination in the center. The different lines correspond to these different amounts of background illumination. And the point here is that a ganglion cell can respond to more than 6 log units of illumination, depending upon the amount of contrast that's present between the center and the surround. This allows vision to happen under a remarkably broad range of environmental conditions. Just as I've been speaking to you in this tutorial, the sun has set and the environmental conditions are much less bright now than they were at the start of this tutorial. Believe it or not, if I were to look at a piece of print, the light reflected from the white paper would be less than the light reflected from the dark print at the start of this tutorial. So what appeared to be dark when the sun was still up still looks dark to me now, even though the amount of light that's being reflected is actually considerably less. And similarly, the white paper still looks white, even though it's now dusky and the sun is going down. So that's just one example of the functions that are illustrated here in this curve, where what our retinas are really conveying to the brain is contrast, defined by edges of light and shadow. Well, I want to show you one example of this, and for this I'm going to pause just a moment and navigate over to the website of a good colleague of mine and friend and mentor, Dr. Dale Purvis, who has one of the best websites that pertains to any field of science available on the World Wide Web. And I would invite you to navigate there yourself. His website is purvislab.net. Well, I've just landed on the website of Dr. Dale Purvis, who you'll recognize as being the senior author and senior editor of the textbook that I've been referring to. Again, a good friend and colleague for many years now here at Duke University, and a mentor of mine throughout the last couple of decades of my career. So I'm going to click on the domain in his website called See for Yourself. And if we go to See for Yourself, I want to draw your attention to one particular animation here under the lightness and brightness category. Now hopefully you can see this dot that's moving back and forth. It's a circular patch, and I hope that as you watch it move, you'll be able to see that there's an apparent change in the brightness of this circular patch as it passes through what looks like a bit of a veil or a bit of a fog. As it moves to the right, we see that it appears to be dark, and then as it moves to the left, it appears to be bright. So there, now it's getting brighter, and then as it moves back to the right, it's getting darker. I hope that's exactly what you see. So here it's getting bright, now it's getting dark. Well, I just want to see if you're paying attention. Of course, that's not what I see, and I hope that's not what you see. As it moves to the left, it's getting dark. You see that? It's getting dark. Now it moves back to the right, it's getting bright. To the left, it's getting dark. To the right, it's getting bright. Well, this is a demonstration of exactly the functions that I showed you in the last slide. So there's a change in the background illumination, and as that happens, our visual system continues to be responsive to the contrast between the center and the surround. Now, if you read a little bit more about what Dr. Purvis has to say about this demonstration, he'll tell you that the physiology of retinal ganglion cells just can't possibly explain this phenomenon. There must be something deeper in how these signals are processed in the brain that gives rise to this percept. And he very well may be correct about that. But all of this begins in the retina, and the physiology of the receptive fields of the ganglion cells has much to say about our ability to detect this patch of gray as it moves across this background illumination. Now, in case any of you have doubted whether this is actually a gray spot, this website has this nice little interactive feature. So here I can just mask out the background and move this with the spot, and you can see that indeed it's a uniform gray spot that moves across this field. And we can let that pass out and see how indeed the luminance is a function of the interaction of the spot and the background. Well, we could spend quite a bit of time here on this website, and I would invite you to do so. I think it's a fascinating set of demonstrations of visual physiology, and we'll look at a few more in our next tutorial.